Let's look at some important words for linear graphs, starting off with Cartesian plane. This graph that we draw here with all the points on it and the two axes is the Cartesian plane. It goes on in all directions to infinity and minus infinity. It never ends. We only ever look at a part of it at a time. The part we look at is a bit like zooming in on your computer to a small part of a document. You know the rest of the document's outside the screenshot, so we're only looking at a bit of it at a time. The next one is a quadrant. There are 4 quadrants on a Cartesian plane. The first quadrant is up here on the right, the second quadrant here, the third quadrant here, and the fourth quadrant there. And each point on the Cartesian plane has coordinates. So this point right in the middle here, its coordinates are 0 and 0 because I've moved nowhere in the x direction and nowhere in the y direction, so I'm at the middle. Another point over here, this one here, is minus 1, 2, 3, 4, 5, 6, so minus 6 and plus 1 up in the y direction. So minus 6 plus 1. Of course, any point in between can also be given a coordinate. So even this one in the middle here, which is right in the centre there, for its coordinates will be minus 1, 2, 3, 4, minus 3.5, and plus 1, 2, 2.5. And you can have all sorts of fractions as well. For our linear graphs, there are 2 sorts of variables, x and y. X is called the independent variable because we can change it to whatever we like. Y is called the dependent variable because its number depends on what x was. The last word we've got here is the origin. The origin is the point where all coordinates come from. So if I'm 5 across and 2 up, I'm always starting at the origin to work out where the point is. A formula is actually just a rule like y equals mx plus c that helps you work something out. For linear graphs, we also call that a linear relation because it relates x and y. So for now, we can use both of those to talk about the formula or the linear relation. A line segment is a bit of a line. If I use y equals mxc and draw the graph of it, it goes on forever off the screen, off to infinity in both directions. So we call that a line. A line segment is a bit of a line. So here is a line segment. It stops here at this point and stops at this point. It doesn't go off to infinity like this line would and like this equation would. The gradient of a graph determines how steep the graph is, and we work that out by doing rise over run. So we make a triangle, we find out what the rise is, what the run is, and we divide rise divided by run, and that gives us the gradient. The x-intercept is where the graph crosses the x-axis, just here. The y-intercept is where it crosses the y-axis, just here. So intercepts are where something crosses. The last word is linear graph. A linear graph just means a graph that is in a straight line, like this one. When you have a straight line, the gradient is the same all the way along the line. So walking up this line would be just as steep if that was a hill, wherever I was. You probably do know the word parallel. Parallel just means 2 lines that are in the same direction, they have the same gradient, and no matter how long you make them, they never meet. A bit like train tracks, but straight. Perpendicular, on the other hand, means at 90 degrees. So here are 2 line segments at 90 degrees. This line segment and this line segment are 90 degrees to each other, so they're perpendicular. these two are parallel.